We tend to look at solid objects around us and assume that stability is their natural default state. When something cracks, ages, or fails, we treat it as an anomaly, a specific structural failure to be solved. The real mystery is how anything manages to hold its shape at all. Take a look at this animated diagram. The large circular boundary represents a macroscopic state, a defined structure. Inside, you see thousands of erratic vector lines. These trace the trajectories of individual particles, representing the microscopic arrangements compatible with that larger boundary. In accepted physics, entropy is a measure of these statistics. It calculates the raw probability of how many ways you can arrange the microscopic pieces, while keeping the macroscopic shape intact. The math is entirely one-sided. An isolated system will always drift towards dispersal, simply because there are infinitely more ways to be scattered than there are ways to be whole. The universe doesn't actively tear a structure apart. The structure just yields to overwhelming statistical probability. Despite those odds, matter does occasionally lock into recognizable organized shapes. Massive stars ignite, biological cells divide, and steel bridges span rivers. These formations survive because they are not isolated systems. They rely on a constant intake of energy, rigid physical constraints, and internal feedback loops to offset the mathematical pull of dispersion. The physical mechanisms to stave off decay are specific to the domain. A living mammalian body uses metabolic bonds. A star relies on intense heat flow and gravity to prevent itself from drifting into the vacuum. A skyscraper distributes its load straight down to the bedrock. Mainstream thermodynamics explains these specific physical mechanics perfectly, but General Emergence Mechanics, or GEM, approaches this from a slightly different angle. It is not a replacement for thermodynamics, a geometric question beneath it. Maintaining any physical state against the vast tide of probability requires continuous effort. Physical existence is an ongoing mathematical struggle. If we view a structure geometrically, we can map its lifespan. This bright vector line advancing from left to right represents an admissible route. It is a highly ordered path cutting straight through a chaotic web of fading, dispersed pathways. Notice how the tight line pulses as it deflects the branches away. To maintain its strict, linear trajectory, the system must continually refuse the wider, easier paths of dispersion. That refusal requires constant work. You can see a solid area graph filling in beneath the advancing line. That growing metric represents the coherence cost. It is the accumulating mathematical toll generated every single time the system pushes back against scattering. The forensic reality of this framework leaves no room for exception. No route holds for free. As long as the structure resists probability, the toll mounts. Persistence is never free. We can translate this geometric cost directly into physical reality. When a star burns through its hydrogen fuel or a body metabolizes calories, they are making literal, continuous payments against that coherence cost. A structure is stable only while its route can still pay the cost of coherence. Every passing second adds another entry to the mathematical ledger. As the duration of the structure increases, the total effort required to maintain its boundaries scales up right alongside it. Structural survival is a temporary clearance. It is maintained by an exhausting series of transactions against an inescapable cosmic audit. This entirely removes the malicious reputation surrounding entropy. It is not a destructive force. It is simply the universal accounting system. Entropy is not the enemy of structure. It is the bill every structure eventually receives. Physical destruction, whether it is the aging of tissue, the cracking of concrete, or the decay of an isotope, is the inevitable default to probability. The resources to stave off the statistics finally run out. Collapse is what happens when the route can no longer afford itself. Any perceived stability is an illusion. A solid object is just experiencing a temporary stay of execution, functioning without a permanent exemption from the laws of probability. The final question is not whether a thing exists. The final question is whether it can still afford to hold. If you want the written foundations behind this series, the books, papers, and playlists are linked below. The videos are the gateway. The books and papers are the foundation layer.